Good afternoon, class. Over the course of the last 2 months, we have been tasked with creating an information system that is consistent with the business case regarding a bike-sharing service to be implemented within an entire city. To finalize this task, we must analyze our system design process by outlining the steps we took to ensure we properly associated all components with each requirement. We must also decipher our logical reasoning behind the methods of system creation with association to hardware and software requirements. Finally, we must plan ahead for this information system to reach completion with a focus on analytical processing to ensure that all systems are operational. When I realized that we were going to design, code, and implement this system, my mind began racing to think of all the possible routes of execution. The origin of this process began with a business case. This business case outlines some extremely critical requirements for the system. To begin, it dictated that this bike-sharing system will operate from kiosk-based stations that house 2 bicycles each, and that they will remain updated in real time with asset availability for the consumers. From this basis alone, I was able to determine that the main hardware components are already accounted for, that we must have a network-capable service with multi-device compatibility and accessibility, and that within our code we must fire messages throughout the network to update the consumer base at all times of asset availability. Reading further into the business case, we find that not only does each user have 2 options of membership to utilize the service, but that the duration of their use dictates their individual cost. Each user can either purchase a 1-day pass for $5 or a year-long pass for $70. Additionally, each individual ride comes with a cost broken down by the minute. A 0 to 30 minute ride is free. A 31 to 60 minute ride is $1. A 60 to 120 minute ride is $5. And anything from 121 minutes or more is $7. Finally, a fee of $50 will be issued if the asset is not returned within 600 minutes or 10 hours. Thinking of all of these variables associated to cost makes me realize that we are going to need some level of data storage capability, as well as some way to track each individual's membership status and ride duration within the coding process. Now that I have defined the simplistic nature of the system from a high-level view, we must dive down a little further to determine some of the more specific requirements with relation to hardware and software. I prefer to cover the hardware requirements and determinations before software due to the innate limitations that exist within hardware capabilities. For this reason, I outlined some key components that are necessary for the system to operate according to our client's requirements. In addition to the previously mentioned asset docking station, we would need networking equipment, a mainframe computer with a touchscreen, and a credit card reader. Once these key devices are dictated, we can then work through our requirements to ensure that we are covering all of them. As we recall each item, we can connect them with their respective software counterparts. The network equipment will be supported by a network system framework program that encapsulates all necessities to run, maintain, and upgrade the network as necessary. Another facet of this capability that we must provide software for is its intended purpose, which is to provide information to our consumers in an accessible and compatible manner. This will be accomplished with the integration of a web-based development that will run on HTML5 and CSS3 with integrated device support. The mainframe computer with touchscreen will coordinate all data between our network and the user while registering for their membership, paying any due fees and/or fines, and determining their desired usage. This will operate on a Windows-based system and have basic functionality support through a graphic user interface that will provide easy-to-use accessibility. The credit card reader will obtain its support from a combined effort of the mainframe computing system and the networking system to ensure that all data transfer occurs appropriately. Finally, the asset docking station will be supported by an independent program that will communicate between the mainframe system and across the network to ensure that assets are locked, unlocked, and tracked within the parameters of our client's requirements. After all of these steps are accomplished, there are a few more items that must be considered before a full-scale production of the system as a whole can begin. Items for consideration include the following: system security requirements, both physical and digital. Physical security measures are typically much easier to plan for as they are tangible. For this design, I determined that encapsulating our equipment within and underneath the kiosk would provide a wonderful hiding place. Also, alarms that were controlled from a remote location would also provide heightened physical firewalls. Digitally, we will integrate a reliable and constantly updated antivirus and firewall to ensure that little to no issues would arise within our system. Network communication priorities and frequencies. Asset accessibility is paramount to the success of this business model and therefore must be number one priority. With this in mind, user account creation must have the same priority as transference of information between users and asset availability. This will ensure that our users, both new and existing, can obtain the same level of service. Maintenance and routine message transference will occur at a lower priority or varying times of the day to ensure that the system communicates effectively and efficiently at all times. Finally, information security with specific focus on protection of user information, which is also known as personally identifiable information, or PII. All PII will therefore be stored on a cloud-based server that exists within a secured area with access limitations to prevent any physical access failures. Additionally, this storage system will be monitored 24/7 for active malicious attacks or attempts to gain access to the system. Finally, with all of these steps outlined, we are ready to begin the software development process, which begins with pseudocoding and model creation with an innate understanding of the end result and inter-system dependencies. After this process concludes and the software is generated, we are ready to finalize the production of the system to our clients. The most problematic step of this entire process is ensuring that all systems operate as intended with no additional conflicts or issues. Each kiosk will need to be integrated with its software, tested, and so slowly added to the network to ensure proper functionality and system support is given without overloading the system as a whole. The final implementation plan is as follows. We'll assemble all kiosk systems, integrate software with hardware, cold start systems to ensure they are functional at a base level with no other system interfaces, individually introduce inter-system communication within each kiosk to ensure that all systems communicate and operate as expected. Once these have all been independently integrated into the system as a whole, we must begin the process of full system integration. This is conducted with constant monitoring to ensure that no conflicts occur. If a conflict arises, it must be rectified before this process can continue. After the first kiosk is verified to be entirely functional, it can be installed at its first geographical location. Each subsequent system, as they become available from software integration and testing, can be installed at its respective location. The key to continuous success between our business and the client is an open line of communication and constant support from both parties. Communicating the delivery process and any associated delays with our client is paramount to the effective, efficient, and quality production of their system. Thank you for taking the time to watch my presentation regarding this lengthy project, and I wish you all the best in your future educational endeavors.